So on the back page, they give us a little flow chart. And sometimes I think flow charts are kind of confusing. But this actually, like if you think about it as a decision tree, it actually is pretty helpful. If you can do it by just eliminating a variable by just adding them together or multiplying by -1, then do that. Just add them together. Or just multiply by -1. That's super easy, and do that. So if you can, then sure, do that. But if you can't, you have some other options. Okay, could you multiply just one of the equations so you can eliminate? If you can, you should do that. But then what we're learning today is sometimes you can't do that. You have to multiply both equations. Let's take a look at these examples and see how they fit in with that decision chart up above. Okay, can you eliminate by simply adding or multiplying by -1? If you look at this, if we added these together, would anything drop off? Yeah, it would, wouldn't it? The 4x would. So we can just do that. If we can, just do it. That comes out to be 0. This comes out to be 6y, because -2 plus 8 is 6. And -12 and -24 gives me a -36. Now I just have to solve it, so I'm going to divide by 6, and I get y equals -36 divided by 6 is a -6. And then, of course, I can plug that in to find my z, or my x. So I kind of like the bottom one because there's, I don't know, the negatives always bother me. So the bottom one, 4x plus 8 times -6 is -24. So that's 4x minus 48 is -24. We're going to add 48 to both sides. So that's 4x is equal to 24. Divide by 4. We get x equals 6. We have x equals 6. We have y equals -6. So this answer should be 6, -6. Of course, we can check our answer. 4 times 6 is 24. 8 times -6 is -48. That does up to -12. 4 times 6, -4 times 6 is -24. Minus negative is plus 12. Yes, that does work. So these do work. It's 6, -6. Let's go back to our decision tree. 5x, 3y, or 5x, 3x, 4y, and 9y. We want to look up and see if any of those kind of match up in any way. Is there something we can multiply where we just multiply one of the equations? I'm not seeing it. I'm not seeing it. So what I'm going to do is that method I was just talking about a second ago, where we just multiply this one times 3 and this one times 5. But of those 4 numbers, one of them has to be negative, so I'm going to make that a -5. So now if I multiply this top equation, I'm going to get 15x plus 12y. And on the end, that's going to be a -90. In the bottom equation, when I multiply that, we get a -15x. And negative times negative is a positive 45y. And -5 times -18, I'm going to go to my calculator, and that does give me 90. Positive 90. Okay, add these together. 15 and -15 drops off. 12 and 45, that's 57y. 90 and -90, though, is 0. Okay, we've talked about this before, I think. Don't let that 0 freak you out. The 0 is okay, because we divide by 57, and we still get y equals 0. I have my y. I need to find my x. I'm going to plug into the top equation and get 5x plus 4 times 0 is equal to -30. That is 5x equals -30. That is divide by 5, and x is -6. So the answer should be -6, 0. I kind of just did it in the top one, so I need to check it in the bottom one. That's a -18 minus 0. Yes, it does work. It does check out. All right, this next problem, think about our decision tree. Is there a way that we can just add them straight together? Okay, no, because the 5 and the 10 don't match, the 7 and the 1 don't match, no. Could you multiply one of them? Yeah, we actually could. And then if you can't, then you can do both. So in other words, like I was saying before, like if you just don't get this, let me show you what you could do. I need to make some space, so I'm going to move that over. What you could do is you could multiply this one times 10, this one times 5, make one of them negative. You could do that. It would work. To me, though, that seems like the long way. And if I just take a second to think about it, it looks like I've got a couple of options here now. One is I could multiply the top one times negative 2, because that would give me the 5, that gives me a negative 10x and a positive 10x. I could do that. The other option is if I look at the y, I could actually just multiply this top one times 7 to get rid of that 7 and negative 7. Either way. I kind of like the 7 just because whenever I say the y all by itself, this is the method I use. It just seems more obvious. I'm going to pick a different color so that it works better for us, so we can see what we're doing. So if we multiply that, everything times 7, we get 35x plus 7y equals 63. And the bottom equation does not need to be multiplied. We can just keep it the same way it was. That's the shorter way. Okay, so 35 and 10, oh, do I have a negative? Yeah, I do. Okay, 35 and 10 is 45x. The 7y and negative 7y drop off. Oh, this is hard to read. It's supposed to be 63 and negative 18. So we're going to go to our calculator and take 63 minus 18, and that seems like 45. Oh, good. That makes it easy to do, right? So 45 divided by 45, x is 1. I need to find my y, so I'm going to plug that in. I think I'm going to use the top one. 5 times 1 plus y is equal to 9. 5 plus y is equal to 9. Think about it logically. 5 plus what equals 9? You could probably know that. Algebraically, we would subtract, but you can do it logically if that helps you. Okay, so y is 4, because 4 plus 5 is 9. All right, so my answer should be 1, 4. And I kind of just did it in the top equation. I'll take a second to it in the bottom equation. 10 minus 28, yes, that is negative 18. It does work. Okay, the gist of this is very similar to yesterday. The only new thing is sometimes you have to multiply both equations instead of just multiplying one equation.